In this video, we will continue on discussing the natural logarithm by reminding you of a few common properties. So here, a and b represent positive numbers, r is any rational number. So hopefully familiar properties from a pre-calculus or algebra course. The natural log of a product can be split up into the natural log of the sum. So ln of ab is ln of a plus ln of b. The natural log of this quotient becomes the natural log of a, the top, minus natural log of b, the bottom. If you have a constant in front of the natural log, you can pull that in, as we discussed previously, and make it a power inside the natural log. Also, as we mentioned previously, the natural log of 1 is 0, and another common value that we will discuss in the future is that the natural log of e is equal to 1, and it's just worth mentioning here as a reminder. Another property related to logarithms, something that will come up later, but worth mentioning now just to kind of foreshadow a bit, if you have a log with a different base b, something we will define later on, you can rewrite it in terms of natural logs, natural log x over natural log of b. With that in mind, and if we remember our formula for differentiating the natural log, we should be able to differentiate, just for fun at this point, the derivative of log base NEB. And we can do so by rewriting it in terms of the change of base formula. So that's really ln of x over ln of b. ln of b is simply a number, so we can think of having a 1 over ln of b, which is a constant, which we can pull in front of the derivative. And what remains is just the derivative of the natural log of x, which we know is 1 over x. So just mentioning this here, but it is something that will come up later. So let's look at a few very basic simplifications where we're going to give you an expression, such as the one here, and the idea is just, can we somehow combine it into a single logarithm? Well, if you have a natural log plus a natural log, you can use this first property, but not when there's a constant out front. We have to take care of that first with this third property. So we can think of 1/3 as becoming the power of 8 inside that second natural log. So we have the natural log of 3 plus the natural log of 8 raised to the 1/3 power. 8 raised to the 1/3 power is really the cube root of 8, which is 2. And now we have a natural log plus a natural log with no constants involved out front. So we simply need to take the a and the b, our 3 and 2, and multiply them together. So this is a natural log of 3 times 2, which is the natural log of 6. So one more example here, very similar in nature, but now I'm going to go ahead and ask it involving log different base, so those same properties hold, and involve some more general looking quantities, so in a, instead of necessarily all constants. So the first thing I'm going to observe is we could combine these first two logarithms together, and then secondly we can take this 1/3 and make it a power inside the log. So we can write this as log base 10 of 4 over a minus, and then I'm going to take the 1/3 in front of this logarithm and move it inside. So minus log base 10 of a plus 1 to the 1/3. Now we once again have a logarithm minus a logarithm, so we can combine that into a single logarithm, where we would have the logarithm of 4 over a divided by the logarithm of a plus 1 to the 1/3, which is really just the cube root of a plus 1. Now I'm going to take this one more step in terms of simplifying and just remind you in fractions, if you have a over b divided by c, that really you could think of this c on the bottom as being c over 1, And dividing by a fraction is multiplying it by its reciprocal. So this would be a over bc. How I choose to think about this is instead of maybe dividing by that 1 on the bottom, what we can think of doing is just taking this fraction and kind of dropping it down a level. So combine together those two denominators, a over bc. So with that in mind, our simplification is that we have log base 10 of 4 divided by, and I'll just drop that down a level. So a times the cube root of a plus 1.